So today I'm going to talk about covalent bonds. I made a video yesterday about ionic bonds. So one of the main differences between ionic bonds and covalent bonds is that ionic bonds, they're going to be a transfer of electrons between a metal and a non-metal. Here, a covalent bond is going to be the sharing of electrons between two non-metals. So there's the difference between them. So you can have a single bond. So a single bond is going to be denoted with one line. So that one line just means two electrons. So you can also draw it like this, having one line, and then you can see the two electrons on the other side. If you have a double bond, it's going to have four electrons total. You're having two single bonds together, like one, two individual lines. Both of these individual lines, they're going to be denoting for four electrons. You can see that right here. You can count them: one, two, three, four. When you come over here to the triple bond, you're having three single lines in there. When you see the three single lines, each one is having two electrons. So when you look at it over here, you can see one, two, three, four, five, six. That's six electrons total. So when you look at a single bond example, we're looking at methane here. So CH4. So you got one carbon in the middle bound to four hydrogens. You can see this single bond right here, and it's going to be having two electrons, one on each side. Same thing with this hydrogen with this carbon here. You're going to have one bond, a single bond. Here is two electrons, one on each side. So when you look at the molecule over here with the orbitals or the electron clouds around it, you can see in the outermost valence shell, which is this outermost shell all the way the outside of carbon, this is where the electrons are going to be having their interactions. So you can see this hydrogen here over on the right side of this of the CH4. And when you look at it over here, the same hydrogen, you can see these same two electrons, one, two, and you can see that same line there, one, two. Those are two electrons. So for a double bond, we're looking at oxygen gas, which is O2. So that's going to have four electrons total. You can see it, one, two, three, four. It's having four electrons. So when you look over here with the orbit or with the electron clouds around it, in the outermost valence shell, what you're seeing in the middle where they're sharing these electrons, you can see four electrons. Here's one, two, three, four. Those would each individually be aligned so you could see it having its double bond there. Over here, we're looking at N2 or nitrogen gas. So in the middle, they have a triple bond between these two atoms. So here you're looking at nitrogen, nitrogen. Each one of these lines is having two electrons, so you have two, four, six electrons total. So when you look at these electron clouds or the outermost valence shell of nitrogen, you're seeing that in the middle where they're sharing these electrons, you're having six. So there's one, two, three, four, five, six. It's the same thing as over here. They're having a triple bond, so two electrons per bond. You got six electrons in there. So that brings me to another thing. You can have a non-polar covalent bond or you can have a polar covalent bond. And this is all depending upon the electronegativity of the different elements. So when you're looking for electronegativity, it's literally just protons being attracted to electrons. So it just all of the electrons are going to have an attraction with the protons. They're going to have this interaction together because of this, because one's positive and one's negative. So having a high electronegativity, all that means is that you're greedy for electrons. So when you look at the periodic table up here, you can see this red line I drew, or red arrow that I drew all the way across the periodic table. So everything on this left side is going to be least electronegative, and then everything going towards the top right of the periodic table is going to be the most electronegative or have the highest electronegativity. So when we look at a nonpolar covalent bond, so we can just look at methane again, so CH4. So this is a non-polar covalent bond because they're having an equal sharing of electrons. So the carbon in the middle is having four hydrogens attached to it. It's having all four of the same single bonds. We saw that earlier. Hydrogen is at the top left of the periodic table. It has the least electronegativity. So because it's all four of these are having the same electronegativity. They're having an equal sharing of electrons. So basically what's happening is like it's a tug of war between the different elements. So because the four hydrogens, they're all the same strength, this hydrogen can pick up the same amount of weight as this hydrogen, the same amount of weight as this hydrogen. So because that, when they're both pulling on the rope or pulling on the electrons, they're the same strength, so they're not going to be pulling any more than the other. So this gives you a non-covalent bond because it's an equal sharing. So when you look at a polar covalent bond, what happens is they get the creation of what's called a dipole moment. In literal terms, dipole just means two poles. You can think about it as a north pole and a south pole. Here you can see this north pole up here. It's this partial negative. And then down here on the bottom side, you can see the south pole. It's this partial positive that you're looking at. The reason why this molecule is partially negative and partially positive is because if you look back at a periodic table, you'll see that oxygen is right next to fluorine. These are elements that have high electronegativity, meaning that they are really greedy for electrons. So when you look at the inside of where you look at the oxygen in the middle, you're seeing how all the electrons are pulled towards it because it is greedy for electrons. Again, hydrogen is not having a high electronegativity, meaning that it's not going to be greedy for these electrons. So because of this, it creates a partial positive because the electrons carry a negative charge. So they're pulling them away from the two hydrogen elements. So because of that, this creates a partial positive side and then a partial negative. And then over here, I drew the same thing again, but what I drew is in yellow is like I kind of just highlighted over the oxygen so that you could see that this is more where the electrons are circling around this oxygen atom. This is where they're spending their time. I didn't highlight or color in on the hydrogen side because they're not having the electrons spending that much time around them. It's because the oxygen is more greedy. So because of that, a polar covalent bond is going to be an unequal sharing of electrons. And this is because one electron or one element is going to be greedier for electrons than the other.